Let's take a look at Mastery Items, Week 9, Part B. Question number 1. Using the equation force equals mass times acceleration, determine the missing variable if you know the following. This is a common physics formula that you'll use. In the future, it's simple. It's just two numbers being multiplied together to give you a force. 1a. Mass is 5, acceleration is 2. I left the units off. I just want you to be able to do the math. So we're going to write out our formula. Force is equal to mass times acceleration. So in this case, force is equal to 5 times 2, or our force is equal to 10. So we write that up here. Force is equal to 10. Easy enough. 1b. We have our mass and our acceleration again. So formula is force equal to mass times acceleration. Force is equal to 8 times 0.4. And we just multiply those two numbers together to get 3.2. There's no units. In physics class there would be units, but I just didn't put any units here. So we're going to write that up. F is equal to 3.2. All right, let's take a look at letter C. This time we know the force, we have a mass. We're asked to find the acceleration. So we write out our formula. Force equal to mass times acceleration. 12 is equal to 2 times our acceleration. Well, we just divide both sides by 2 to get our acceleration. We get our acceleration is equal to 6. You need to know how to work a formula for every variable involved. So 6 is equal, acceleration is equal to 6. All right, looks like we're doing the same thing over here. Force is equal to mass times acceleration. I always write my formula out. It's a habit I've started when I was in grade school. Write your formula out first, fill in your variables. 17 is equal to 3 times a. Divide both sides by 3. And our acceleration is equal to 17 over 3. And 17 over 3 is equal to 5.7. Well, it's equal to 5.6 repeating 6, but 5.7 is a good decimal approximation. And that's how we work with that formula. Question number 2. Determine the lateral surface area of a cone giving the following information. If you remember, determining the surface area of a cone. Surface area of a cone is equal to pi rs, that's the lateral part, plus pi r squared. That would be the bottom or top of the cone. We're only asked about the lateral part, so we need the radius and the slant height. In letter 2a, we have the radius and the slant height, so it's very simple. I'm going to write out my formula again. Pi rs, so surface area is equal to pi times 0.6 times 1.1. So our surface area is going to equal to 0.66 pi meters squared. That's a fairly exact number, but if I want to figure out a decimal approximation for it, 0.66 times pi. 0.66 times pi, 2.1. meters squared. So our surface area, the lateral surface area, is equal to 2.1 meters squared. All right, let's look at the second cone. That doesn't look like we have either the radius or the slant height. We have the diameter and the height. Well, getting the radius is easy. The radius is equal to 5 centimeters. And h stands for our perpendicular height. So I'm going to draw out a quick cone just to take a look. We've got our perpendicular height here is 12. And our radius here is 5. We're trying to figure out our slant height. So we're going to use a squared plus b squared equals c squared. Well, we do 12 squared is 144 plus 5 squared is 25. Add them together to get 169. Square root that, we get a slant height of 13 centimeters. So our slant height is equal to 13 centimeters. the slant height has to be the longest of the three sides. This is another common Pythagorean triple that people generally know, 5, 12, 13 triangle. So to do our surface area, surface area is equal to pi, well, surface area of our lateral part, pi rs. So surface area of our lateral part is equal to pi times the radius of 5 times 13. So our surface area of the lateral is equal to 5 times 13 is 65 pi centimeters squared. That's the exact value. To get the decimal approximation, I do 65 times pi, 204.2. So our surface area lateral is equal to 204.2 centimeters squared. All right, so you should be able to use formulas from Chapter 1. Remember what they are and how they work. Number 3. Determine the resultant vector by adding these two vectors. So we got vector A is 15 newtons, that's a measure of force, in the direction of east, and 8 newtons south. So I'm going to sketch out what's going on here. I'm starting here, and I'm going 15 newtons to the east. Then my second one is going 8 newtons to the south. My resultant vector is from my start to my end. So first thing, I'm going to use Pythagoras' theorem to determine the length of my resultant vector. So I put in 15 squared plus 8 squared is equal to c squared. Well, 15 squared is 225 plus 8 squared is 289. So c squared is equal to 289. And I square root that and I get 17. Hey, this is another nice Pythagorean triple. Now, we need to determine the size of this angle. To do that, I have my opposite and my adjacent side, so I'm going to use tangent. So tangent of my angle is equal to my opposite over my adjacent side. Tangent my angle is equal to 8 over 15. Now I do 8 divided by 15 to get that into a decimal form, because my calculator works best with decimal forms. So tangent of the angle is equal to 0.53, repeating 3. And then I second function tan that to get 28 degrees. All right, so let's write out our resultant vector. Our resultant vector is equal to 17 newtons in the direction of east. Then it turns 28 degrees to the south. All right, if you have any questions about this, please put them in the comments